Hi everyone, and thanks for tuning into our video on applications of systems of equations. We're going to spend about 2 days on this, and this is just going to be our first 2 examples, which we're calling our notes. And this is just taking some of the methods we've been using to solve systems of equations and actually applying them to a problem. So let's take a look at example 1. It says the sum of 2 numbers is 98. And the difference between them is 48. Find the 2 numbers. And if you look below, I've already written the system of equations for us. So you can see here, most likely what I did, even though I didn't write it, is I defined my variables. Now your variables are what you're looking for. So when I'm doing an application problem, one of the first things I do is I read the problem 2 or 3 times if necessary, and I highlight what I'm looking for. So if you read this problem again, what I'm looking for, which by the way tends to be in the last sentence oftentimes, is I'm looking for 2 numbers. It says find the 2 numbers. Well, whatever you're looking for becomes your variable, because we use variables to hold the place for items we don't know yet. So when it says find the 2 numbers, I'm going to define my variables. And so I'm going to let x equal the first number that I'm looking for. And I'm going to let y equal the other number, or the second number that I'm looking for, since I'm looking for 2 numbers. So let x equal the first number and let y equal the second number. So now you can see that the sum means addition. So you can see that the sum of the 2 numbers is equal to 98. And you can also see that their difference, which means subtraction, so the difference between the 2 numbers is 48. And so the system is written. And now we think to ourselves, okay, well, we want to solve for our variables, so we want to find x and y. What method of the 3 that we studied would be the best? And I'm thinking, well, both equations are given in standard form, and the method that lends itself best to standard form is elimination. So I'm thinking I'm going to solve this system using the elimination method. And more than that, if you take a look at your y's, you have a positive y and a negative y, which will automatically eliminate by the additive inverse property. So I can just go right ahead and add straight down, which makes this system really nice. So when I add straight down, I basically have 1x plus another 1x, which is going to give me 2x, and my y's eliminate, equals 98 plus 48 is going to be 146. And when I divide both sides by 2, I'm going to end up with x equals 73. So my first number is 73. To find my second number, I just take either of my equations. I'm going to use the top equation and replace the x with 73. So 73 plus y equals 98. And to solve this, I can just subtract 73 from both sides. And so my y equals, looks like 25. And then to check it, well, let's see. So if I check this, let's see what happens if I find the sum of my 2 numbers. 73 plus 25, well, indeed, that's 98. So that checks out. And let's find the difference between them. 73 minus 25, is that 48? Indeed it is. So I defined my variables, I solved my system, and I ran a check, and everything's looking great. So this would be an example of a pretty simplistic application of a system of equations. Okay, let's take a look at example 2, because in example 2, I did not write the system. We're going to have to write it for ourselves. I mean, I gave a little hint, but that's about it. So let's go ahead and read it. Michelle sold 12 sweatshirts and collected $320. Hooded sweatshirts cost $40 and lightweight sweatshirts cost $20. How many hooded and how many lightweight sweatshirts did Michelle sell? Okay, so you read it. If you need to read it a couple more times, please feel free. Sometimes just the more you read something out loud or to yourself, the more it sinks in what they're really asking. But once you do that, you have to start by defining your variables. What are we trying to find? We want to define those variables. So again, I said earlier, it typically comes in the last sentence of the problem. So if you look here at the question, how many hooded and how many light sweatshirts did Michelle sell? That's what we need to find out. That's what we don't know. How many of these did she sell and how many of these did she sell? So why don't we let's let H equal the number of hooded sweatshirts sold. I like to use variables that make sense, H for hooded. And then let's let L equal the number of lightweight or light sweatshirts sold. Sweatshirts sold. Okay, so we're looking for H. In the end of this problem, we're looking for H and we're looking for L. How many? Number of. Okay, now we're ready to write our system of equations. Now, the little hints that I gave you. Typically, when doing a problem like this that involves money, there's always a money equation, but there's also then a non-money equation, which I call a quantity equation. So the quantity equation I wrote first here. This is basically just like, how many of these items did you sell all together? It has nothing to do with money. It's just quantity, like how many did you sell? And so that comes in the very first sentence. This number 12 right here. Michelle sold 12 sweatshirts altogether. There is your quantity. So basically, if we take our H, the number of hooded sweatshirts sold, added to the number of lightweight sweatshirts sold, makes a total of 12. That's the quantity equation. Notice, no money. Now we're going to move on to the money equation. Now the money equation has to do, obviously, with total amount of money and how much each of our separate items cost. So let's look at this. So a hooded sweatshirt costs $40 per, which means multiplication, $40 per sweatshirt. So I can write that as $40 times the number of hooded sweatshirts that I sell. This is going to show me how much money I bring in on hooded sweatshirts. So if I sell 3, if H is 3, I bring in $120. If H is 4, I bring in $160. So $40 for every hooded sweatshirt added to $20 for every lightweight sweatshirt sold will total up the total amount of money that Michelle collected, which is the $320. And there we have it. So altogether, we sold 12 sweatshirts. And altogether, when we collected this amount on a hooded sweatshirt plus this amount for every lightweight, this is the total amount of money we collected. So this is our money equation. And now all that's left to do is solve. I'm thinking elimination method is going to be our best bet once again. because both equations are in standard form. But unlike the easy first example, right now we do not have a situation where our h's or our l's are going to drop right out. But it's a pretty quick fix on how we can get that to happen. Since the coefficients of this h and this l are both 1, we can probably just multiply the top equation by either a 40 or a 20, just making sure we make it negative so that our positive and our negative cancels out. So I'm just going to go with what's in the front, and I'm going to multiply by negative 40. So I'm going to have to distribute the negative 40 through, and I'm going to grab a calculator here as well, because I see some tougher calculations coming here. So when we start to distribute, let's see, negative 40 times h is negative 40h. Negative 40 times L is negative 40L. And negative 40 times 12, let's see what that is. Negative 40 times 12 is negative 480. The bottom equation, I'm just going to recopy. 40h plus 20L is equal to 320. And now I'm going to add straight down. If I did everything right, something's going to eliminate, and ensure it does right here. Negative 40h and positive 40h eliminate. Negative 40L plus 20L is negative 20L. And negative 480 plus 320, let's see what that is, plus 320 is negative 160. And we're going to go ahead and divide both sides by negative 20. And so L will be negative 160 divided by negative 20, which is 8. So that means since L is holding the place for the number of lightweight sweatshirts sold, we now know, and I'm going to write it over here, Michelle sold 8 lightweight sweatshirts. Should always finish your problem by answering the question. Okay, Michelle sold 8 lightweight sweatshirts. Now, to find how many hooded sweatshirts she sold, we can simply take 8 and replace it for L in this top equation. So that will look like this. I'm going to switch colors here. So let's say H plus 8 equals 12. And when we subtract 8 from both sides, we see that H is 4. So Michelle sold 8 lightweight sweatshirts. Michelle sold 4 hooded sweatshirts. Now what I want to do is check it, see if it makes sense. So let's check it out. So the first question is, does 8 and 4 make a total of 12 sweatshirts? So the first part of my check, I'm going to write it here, 8 lightweights plus 4 hoodies indeed makes 12 total sweatshirts. So that part is good. Remember, this is the number of lightweights and this is the number of hooded. Now I want to see if the money works out. So let's see here. Lightweight sweatshirts, each one costs 20 bucks. So if you have 8 sweatshirts times $20 for each one, and then you've got 4 hoodies, and the hoodies, remember, were $40 for each one, do you get $320? This is a little out of order. I have this a little bit backwards than I had my system written, but it's okay. It doesn't matter. Addition is commutative, so you can switch that around. Okay, so 20 times 8, all right, well, that's 160. And 40 times 4 is also 160. Does that make 320? Yeah, 160 plus 160, that is 320. So it works out, and we know we've got the right answer. All right, very good. So we're going to do some mastery on this, and in the next video, we're going to do one more problem together on applications of systems. So thanks for watching.